Today we're talking about arithmetic sequences. The definition is going to be a sequence where successive terms differ by the same number d. Okay, so we talked about yesterday how this is a constant difference. If you have a constant difference for the first difference, okay, then it's going to be a linear function. Now this term d is going to be referred to as the common difference, which you can see in your equation is going to be right here. So a sub n stands for the nth term. A sub 1 is going to be your first term in the sequence. N is going to be whatever term you're finding, and then d is going to be your common difference. So sometimes you'll see the equation written like this, and the reason why you can write it with an a is you can substitute in any a term. But if this changes, the 1's also going to change. And we'll talk about that later in our notes today. So for example 1, a sequence is given. For A, find the first 5 terms of the sequence. I just gave you guys a couple minutes to do that. So we will find them here. So if I'm finding A sub 1, Kira, how am I doing that? How do I know that A sub 1 is 2?
You have to plug in a sub, like you have to plug in 1 for your n value.
Okay, good. So we're going to plug 1 into our equation, and then my output is going to be 2. So here's your equation. A sub n equals 2 minus n minus 1. So if I plug in 1, 1 minus 1 is 0. A sub 1 is going to be 2. Okay, if I want to find a sub 2, then Peter, what am I going to do to solve for that? Yeah, for n. Okay, so I'm just substituting in my variables. 2 minus 1 is 1, and then 2 minus 1 would be 1. We should do that twice. All right, so let's check ours and see how we did. How did we do for part A? Really? Okay, so once you find your first 5 terms, you're going to ask yourself, what's the common difference? Now, some of them are just going to be easier to see than others. So if I'm going from 2 to 1, 1 to 0, 0 to negative 1, Grant, what's happening each time?
You're adding, or you're subtracting 1.
Yeah, you're just subtracting 1 each time, right? So then my common difference, d, would be negative 1. Right? Now, if you have fractions that are not like terms, sometimes that's a little bit harder to see. So this is the formula for finding the common difference. You can always do a2 minus a1, which a2 is the second term, a1 is the first term. So our a2 is 1. So 1 minus 2 would be negative 1. That's your common difference. Okay, so you can always find it with that formula. Now for part C, it says to graph the terms, bless you, that you found in part A. So let's look at what we found in part A. Hugh, what was our input for part A? So for a sub 1 equals 2, what did you plug in? Yeah, 1. What was our output? 2. So then the point that I'm going to graph is 1, 2. Okay, so Skylar, what's going to be my point on my graph for a sub 2? Yeah, good. Okay, Ben V, what's my next point?
0.
What? Not just 0. Okay, so put them together. What do you got? Okay, so what's your input?
3.
Okay, what's your output?
0.
Okay, so then your point's going to be 3, 0. Okay, so then Ben, what's this one going to be?
So your input's 4 and your output is -1.
Yep.
So it'd be 4 -1.
Yep, exactly. Yep, and then your last one would be 5, negative 2. So for C, when we're graphing this, hey, don't get lazy on me here. Okay, so I know some of you probably already graphed this. How many of you did already? I'm interested to see if you did it right. So remember the first day of 12.1, we talked about the difference between a sequence and a function. Hunter, do you remember what the difference was? Can anybody help me out? What was the difference? Yeah, Lauren.
Function keeps going, sequence stops.
Okay, so a function is gonna keep going on forever. A sequence can go on forever. But what else? Yeah.
You don't connect a sequence by line
Okay, good. Why?
because they're different input values, not everything.
Yeah, so with the sequence, the points are not connected. Okay? And that's because of their domain. Do you guys remember what the domain is for a sequence? The natural numbers, which are the counting numbers. So 1, 2, 3, 4. With a function, what's our domain? All real numbers. So that includes all the numbers in between the counting numbers. So once you plot your points, you are not going to connect them. So you have 1, 2, 2, 1, 3, 0, 4, negative 1, and 5, negative 2. Okay, so it will be a straight line, but you are not going to connect those points because the in-between values are not in the domain of a sequence. You're only plugging in whole numbers for a sequence.
You
Okay.
still write like arrows.
What's that?
Are
No,
the dots
no, no. Because you'll just graph however many terms they tell you. So I put that it is linear, but you do not connect. The domain is the set of natural numbers, which means 1, 2, 3, and then I put comma, dot, 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 because it will keep going up to the end term. Okay, so that is why you don't connect them. Alright, and then for example 2, it says determine whether the sequence is arithmetic. If so, find the common difference. So this is something that you've done in Algebra 2. So if I'm trying to figure out if there's a common difference, do you guys remember how to do that?
Like
Say it again. Oh, no. So like you're going to see if all the first differences are constant. So there's a couple different ways you can do this. You can ask yourself, how do you go from negative 10 to negative 4? Right? So, Peter, what would I do to get from negative 10 to negative 4? Yeah, you'd add 6. Okay? Will, what about from negative 4 to 2? Add 6. Okay. Genevieve, 2 to 8. Add 6. And then, luckily, the last one, you're also going to add 6. So, because the first differences are constant, is this an arithmetic sequence?
Yes.
Yes. Okay, so then you would identify what your D value is, and that would be 6, because that's going to be the common difference. Okay, so you try B. Okay, and then Raph, I'll have you do this one with me. So from negative 2 to 5, what would I add or subtract?
-3.
Yeah, I'd have to subtract 3. What about from negative 5 to negative 11?
-6.
-6. So right now, I know right away that we are not going to have a constant difference, okay? Because those two are not the same, so that is not going to be an arithmetic or arithmetic sequence. Okay, any questions for me on example 2? Alright, let's go to example 3. So example 3 says determine the common difference, the 5th term, the nth term, and the 100th term of the sequence. Okay, so for our first step, go ahead and see if you can find the common difference, which I think a lot of you already have. Okay, Adam, what's our common difference going to be for part A? Okay, good. And you can figure that out either by saying, oh, you're going to subtract 3 each time, or if you do A2 minus A1, 8 minus 11, you're going to get negative 3. Okay, for step 2, I have to find the 5th term. Okay, so McKenna, can you explain explain how we're gonna find the fifth term?
I just like subtracted 3 2 more times.
That, why 2 more times?
Cause that's the, never mind, one more time.
Yeah, one more time, because, yeah, go ahead, say why.
Cause that's the fourth, 2 is like the fourth term, so the fifth term you just have to subtract 3.
Okay, so I have a sub 1 up through a sub 4 given to me. So this is a sub 1, a sub 2, a sub 3, a sub 4. So if I'm going to find the fifth term, all I have to do is take 2 and subtract 3 from it to get my fifth term. Okay, and then for step 3, I'm going to find the nth term. Now, we've been dealing with the nth term a lot lately. Anytime you're finding the nth term, you're really finding what? The nth term is going to be a what? Yeah, it's going to be an equation. Okay, so it's going to be an equation that relates n to the output. So, remember before how you had to find the pattern and write the nth term? Now, if there's a constant difference, you can use this equation. Okay, so we are going to use our equation for an arithmetic sequence. So I want you to see if you can plug in those values and find your equation. Should always be in that form. That's actually a good thing that I'm going to point out. Okay, so what do I plug in for a sub n here? What do I plug in for a sub n? Nothing, right? That's what I'm trying to write the equation. Okay, so you're not going to plug in anything for a sub n here. And then Peter, what's a sub 1? 11, okay, and then what do I plug in for n? Nothing. Okay, whenever you're writing an equation, you have to have an input and an output. N is your input, a sub n is your output. Okay, and then d is going to be -3. Notice how I put this in parentheses? Because your d value is multiplied by n minus 1. So what do I have to make sure I do with the -3? I have to distribute it. Okay, and in some cases you can actually write it in front if you'd rather. So if I distribute -3, -3 times n is -3n, a -3 times -1 is going to be +3. And then I can just rewrite this. I'll often write it in standard form, so like where your variable term is first, where your constant term is second. But if you had 14 minus 3n, that's not a big deal. Okay, and then as I was talking to McKenna, we were looking at the equation from above for example 1, and I just want you to notice how this equation from example 1 does fit into this format, because our a sub 1 is going to be 2. Isn't that true? Isn't that what we found in step 1? Isn't our first term 2? Looking at this, the constant difference would be what? -1. See how the -1 is in front of the parentheses? And then you have the n minus 1 that's similar to the equation. Now, sometimes you will see the equation written like this, where it's not simplified. So just the 11 minus 3n minus 1, which is exactly what you had in example 1. Okay. All right, and then we're going to find the 100 term. By show of hands, how many of you have already done it? Found the 100 term? Okay. So in order to find the 100 term, Jenna, can you tell me how we're going to do that? Yeah, you're going to plug in 100 for? Yeah, for your n value. Okay, so I'm going to use this equation. You could really use either one. So a sub 100 equals negative 3 times 100 plus 14. So negative 300 plus 14, which will give me negative 286. Okay, and if you use the second equation, again, you would get the same thing. So if you use the second equation, you would still get negative 286. All right. Okay, so B has the same directions as A, so I want you to see if you can navigate your way through that. I know you have fractions. Okay, so Hayden, what should we do first for this? What's our step 1?
For the first thing I did is made all of them the same.
Okay, yeah, great. So that's an excellent thing to do. So if you're looking at all of them with the same denominator, this would be 7 over 6, and then tell me what you got and how you got it for the next one.
I made it to 6 and multiplied
Good, okay, so multiply both by 2, and then for the last one, okay, so you still multiply the top and the bottom by 2. Okay, why is that going to be easier for you to find that common difference? Yeah, and so now you can, there's a couple different ways you can do this. What I would do is I would do the A2 minus A1. So the difference is going to be the second term minus the first term. So if I do 10 over 6 minus 7 over 6, I'm going to get 3 over 6, which reduces to what? 1/2. Okay, so then your common difference is going to be 1/2. So I did something similar to what Hayden did. I just made my common denominator when I went to subtract. Okay, so then your D value is going to be 1/2. Now again, if you're finding the fifth term, you can take the last term and then add the common difference. Okay, and then so 1/3 plus 1/2. This would be, this is why what Hayden did is great, because 8/3 he already has is 16 over 6. So when you add that to 1/2 or 3 over 6, you'll get 19 over 6. Gotta practice those fun fractions. Yeah. Say it again, the a sub 1.
What do you mean?
I did
So your third step, you are going to be finding the equation. So you can use a sub n equals the first term plus n minus 1 times 1/2. Okay, so your a sub 1 is 7/6. I'll have to distribute the 1/2 and then combine my like terms. Okay, so remember 1/2 is really 3/6. Okay, so 7/6 minus 3/6 is going to be what? 4/6. What does that reduce to? 2/3. Okay, so then when I write my final answer, it's going to be 1/2 n plus 2/3, or you could also leave it like this. Okay, either one of those will be correct. Okay, and then for the 100 term, we are going to plug in 100 for what variable? Okay, for what variable we're going to plug in 100? N. Okay, so then when I plug in 100, if I do 100 minus 1, I get 99. Okay, so then I'm going to have 99 times 1/2, which is 99/2. Again, I want to get a common denominator. And if I'm going to get a common denominator, I'm going to multiply the top and the bottom by what? By 3, right? Because 2 times 3 is 6. So then I can add straight across. And then I can reduce this. So 3/4 and 6, 2 goes into both. So I'm going to divide them both by 2. Kira.
4, stop, 3.
Yeah.
Can you write it n over 2 plus 2/3?
You can...
Plus 2/3?
Yes, n over 2 plus 2/3.
Yeah.
Yes, you can. Yep, that would be absolutely fine.